Today is July 17th, 2025. Oh my goodness. Thanks for tuning in. This is the Community Code Review, aka the Datum Dons. We are presented and funded by the good people at Gimbalabs, and we explore Aiken Validator code together, line by line, question by question. Let's get into it. Who is the Don and who are the capos? The Don today is Lewis, and the capos are Harsha, CodeCow, and myself, Newman. Hey Don. Hey Don Lewis, are you ready?
I am. Thank you so much,
We
Newman.
You're welcome.
Hello, everybody else. So today we're looking at the DS double spent NFT contract. This was written by one of the capos here, CodeCow. So I hope I do a good job explaining it. So starting us off, I'll do the imports. So, so these imports we get whatever, what's the word? So we're getting the useful modules from the Cardano assets, Cocktail and Mocktail, and the Oracle libraries. Uh, yeah.
Oracle
So the
is not a
policy ID.
library, I think. Oracle
Uh,
is
Ooh,
I think Oracle is just
yeah.
another validator.
Yeah, we don't actually have that in this code base. That's what I was
Yeah.
kind of saying earlier. It's like
So
this is
yeah,
yeah.
so we can't test it, right? Because we don't have these
mm,
guys.
We could pull them
Oh,
easily. Like you have this locally, Harsha.
Yeah.
okay. But I thought
interesting.
the
Okay.
Oracle was meant for, oh my days, I forget the word. Ay, ay, ay. And I'll remember it in a bit, in a second.
I'll pull
So,
those data. I'll pull all that stuff in. Just give me a second, and I'll make the use Oracle stuff just local in this file. So just continue on as if you have that stuff.
Cardano assets here we have from the Cardano assets, we have the policy ID, add and from assets. So the policy ID is used to identify which policy controls the minting or who controls the minting, right? The
Uh,
add,
i-
So the policy ID to me is the NFT. It's like one part of the NFT, right?
so
It's the first part. Yeah.
it is basically a hash of the minting script.
Yeah.
A
hash of the
policy
And
ID
we
is
need
just the hash. Say, for example, this is a minting script, right? All of this because it's a mint test case, sorry, script purpose. So you hash this whole validator, and then
Mhm.
you get the policy ID for this validator. You get the policy ID for the DSNFT.
right.
So would you say it controls the minting?
It basically gives it gives it part of its uniqueness. Every
Mm,
token is minted
Yeah.
by some validator or the other. So this validator becomes a part of the token itself, and that part is called the policy ID.
okay.
Yeah. So think of it
But
like
yeah,
this. Think of it like this.
Mhm.
Uh, Say for every baby that is born, the mother's name is a part of their name. You know what I'm saying?
mm,
So the mother is the script, and the policy ID is the name of the mother, and this becomes a part of the baby itself.
Mm. Okay. I was trying to use an example with my statement, but it makes so much sense.
yeah. And we could also look up the docs because I that's one of my favorite parts of the datum dons is just going through and checking out the
So,
docs because that's
and by the
that's
way,
really
policy ID, P O policy ID is a type, by the way,
Mm.
right?
oh
So because it is capital P, so anything that starts with a capital is a type. So
Oh yeah,
policy
I heard
ID
it.
is nothing but a hash that is derived from the script. This is this total script, and this is the hashing algorithm, which is the Blake 2B224. So you are hashing the script with this algorithm and you get the policy ID, which is the hash. Does it make
Yep.
sense?
Yep.
Yeah.
Yeah. Okay.
Nice.
So continue.
Yeah, go ahead.
Yeah.
Yeah. So now add, as the name suggests, it adds, or rather it combines two assets together, right?
Does it? Maybe it does. Yeah, I don't know actually. Let's go to asset. So we're at asset and we'll go to the function and it's add. So add quantity of a single token to asset. This is more efficient. So what is it doing? So it's a function that takes a value as an input. It takes a policy ID, it takes an asset name, and it takes an integer, and it creates a bigger. Okay, it adds. Okay, got it. So you know how value is defined, right? So if you want to understand this function, you need to understand what value is. Are you guys all like familiar with value?
No, let's look into
So
it.
yeah, value to me right off the top of my head is I always think of that as the um number of ADA. It's a and I don't know if it's exclusive to ADA or if it's any other thing. But it looks like it yeah, I always just think of it as a number of uh ADA. Is that way off?
It is no, it is not way off. It is a part of it. A value is a bigger thing. So value, think of
Right.
value as an object with three fields, three main fields. So think of it as a list of objects, you know,
Okay.
and in the list,
Value.
yeah, the value is a list of objects. Think of it as a list of objects, and in the list, it's each object has three fields. One is policy ID, one is asset name, and one is quantity.
Right.
Okay,
Okay.
so think of it like that. So a value is uh, it's not it's technically not like a not a list. It's more of an object with
Right.
objects within it, you know. You get
Okay.
what I'm saying? So
C-
each field inside is like an object itself.
cruise over to the code.
Mhm.
That sometimes helps out, the triple dots there. No, not our code, but the
Mhm.
code on the library. Like that guy, yeah. Source. Sometimes this helps out, sometimes it's not.
This time it won't.
It doesn't help, does it?
But
No.
I also, okay, so actually it does a little bit. See, look at it. It's a dictionary with
Yes,
policy ID
yeah,
as the key, the asset name
yeah.
and integer value as the value.
Interesting. It's a nested dick.
It's not
Yeah, all right.
an yeah,
Well, look, it's a
it's a nested
dictionary where,
dictionary. Yeah, it's a
yeah,
nested
yeah.
dictionary with policy ID as the key, and the value as the other dictionary, which again has the asset name as the key and the quantity as the value.
So here, timeout for just a second, and excuse me,
Mhm.
Don, while I get in. Go back to our standard library. Where does it talk about that integer? I guess asset name has integer in it. Like I want to see like the way you explained it, Harsha, was really great, but the way this explains it is not so great
So the
because
integer, okay, I'll give you an example. Okay.
okay,
Think of we created like a specific token. It's not an NFT, it's a regular fungible token. Okay.
okay,
The
yeah,
token is created with a specific validator, right? And the
yeah,
hash of that validator is the policy ID of the token.
sure,
Okay.
okay,
And there can be different tokens with the same policy ID but different asset names. Okay, because it's
different
just a name.
tokens,
Same
different
policy ID
token, the
but
same
different
policy.
asset names.
Okay, okay. A little bit. I mean, yeah, I guess I'm
So
trying to
so
think of an
Are
example.
I have a
Go
question,
ahead.
Newman.
uh-huh.
Yeah.
Are is ADA the only first class asset?
Hmm.
No.
So
Is it
Ada is No, it's not. That's actually one of the distinguishing things of Cardano, that they don't have, it's not like in Ethereum where ETH is like its own special object and all the other ones are different. So correct me if I'm wrong, but
You're right.
ADA is a native asset that is just like any other native asset. Is that my?
No,
Yeah.
I have a
So
question.
when I see value, when I think of value, I think of this ability for Cardano's assets to all be native first class citizens, where
Yes.
ADA is Lovelace. And but also like I could have different NFTs, different policy IDs, and all of those are first class citizens just like Lovelace is. And so I don't say it's Lovelace. I call all of these things values. And it does, like when I'm talking about value, it's like I'm talking about the type of either Lovelace or any of the other first class assets that we could have. That's how I think of it.
Okay.
And
Okay.
what do you mean by first class assets?
Right.
It's, yeah, maybe Newman could explain it better, but it's
Yeah.
that idea of the other chains like only have one first class asset and everything else is like secondary. It comes with it as like an
I would
addition.
use the word native, like because they're all
Yeah.
native assets.
Yeah. That would be a good one to sort of, because that is like a fundamental part. And one of the reasons why Cardano has like a, is that third generation type of thing. The way I sort of think of it is that they're all of a type. They all sort of interact in a
Yeah.
similar way, right? Is that
Correct. No,
Yeah, of
that's
value.
100% I look at it, how I look at it. Yeah.
Yeah.
And that's value, right? Like that similar type is value, correct?
Yeah.
Yes.
Correct. Yeah.
Yeah.
I mean,
Okay.
value, I think value is not just one asset, right? Value is it can be one asset or multiple assets. It's how you combine all these tokens together. It's a representation of how you can combine and put these tokens in a transaction.
Yes.
Yeah. Sure.
So here is where we can now, based on what we've just learned about value, let's figure out how we use value in this contract. If you agree.
Yeah. No. So just like a little thing before we jump in, because now we discussed that ADA and other tokens on Cardano are considered native tokens. That means they all behave similarly. I just want to go through one more thing, which is okay. So I'm going to ask you, Newman and Lewis, what do you think is the policy ID and asset name for ADA or Lovelace?
I had a feeling I'm vamping for you, Lewis. Go and start researching. I'm stalling because Harsha does this
No,
sometimes.
you can guess.
Yeah.
I'll just open it, like if it's too
Sorry, could you
confusing.
repeat the question again?
So for ADA, like Lovelace, what do you think will be the policy ID and asset name? Because ADA is just another token on the Cardano blockchain, like a native token on the Cardano blockchain.
So, according to my thinking, like Google, the unique identifier, which is the policy ID. What? Policy ID, the unique identifier that is associated with the minting policy, hash of the minting policy, that's in brackets. And then the asset name, an immutable property of an asset that is used to distinguish different assets with the same policy. Okay, does that make sense?
That is just the policy. So
that makes no sense.
So now I'm saying
Google failed me.
Yeah. Google messed you up on that one.
So let me do ADA policy ID. Okay. So ADA policy ID. ADA, the native currency, isn't associated with the policy ID.
Oh, that was a trick question, Harsha.
But do you know why?
Because you can't mint it. Because you can't mint it.
Exactly.
Yeah.
You can't directly mint it. Otherwise, anyone can mint ADA and then it'll become like worthless.
You see, it's a
So
good thing we digressed on line 6.
that's how far we got, line 6. That's
Yeah.
good. That should be that should be part of our data model. This is like, where do we digress? Where do we go fully off the
Okay.
rail? But this is fundamental though. This is
Yeah.
great.
Yeah. So now you know that policy ID is just an empty byte array for Ada.
So
And what do you
so
think is the
Ada,
asset name? Yeah,
Lovelace.
correct.
That's what I'm
Asset
thinking.
name is Lovelace. Asset name.
Yeah.
Where's this? No, this is where fuck. Ada. Oh, Ada asset name. Yeah. So Ada. Oh, Ada asset name is also empty. I thought it'd be Lovelace, but I guess it's empty. It's another.
Interesting. Interesting.
So
Ada
they both of
policy
them are
ID.
empty.
Okay.
Why is
Fair
it not
enough.
Lovelace?
Yeah,
Beats
good
me.
question.
So
Because you'd need so you need an asset. What does it say? Data isn't associated with any, it's not possible to mint it. So you're not minting it, so you wouldn't need an asset name? That
yeah.
seems a little, and policy ID, I mean, how would you reference it if you
Why
don't
would you
have a
even need the
policy?
policy ID of Ada? Like, for example, if you
Right.
want to build a value with these two, what you pass in is just like the empty arrays here. Say you saw this, right? And say, for
Okay.
example, if you are building Ada here, what you'd
Yeah.
pass in is like an empty array here, and
Yeah.
then you'd pass in an empty array here, and you'll pass in the number of Lovelace in the integer part.
Yeah.
And that's it. And then
And would
this
that give you,
yeah, it'll give you the
and that would give you
value
Ada.
built with Ada. Yeah.
Okay. So now I propose we go and check out how this validator, this AK file, uses value,
Okay. Yeah.
because now I'm like sufficiently like curious.
Yeah. Yeah. Absolutely. How it uses value.
What do you think, Lewis? Is that a pretty
Is
good
that
one? And
No, because this actually uses
oh, we
like
got,
the
yeah, okay.
functions,
It was
direct
from
functions.
add. Yeah. And I
Yeah.
think we got to value through add, I believe.
Correct. So now you understand what add does. It takes an existing value and it adds a specific token to it.
It doesn't
Uh,
multiply.
Okay.
like
It
let's
doesn't
go to
combine
add
two
one more
assets.
time. So
Yeah, let's back
add
out. Let's
asset.
back out of this.
Yeah. Look at this. So there is an initial value it takes in
Yeah.
and it adds a token. And what does
Oh,
it need to add a
shit.
token? It needs the policy ID, it needs the asset name, and it needs the total quantity of the token that we want to input into the value. Make sense?
Lewis?
Yes, it does make sense.
Okay. And then it gets a new value. Okay, cool. Yeah. Go ahead, Lewis. I feel like I'm taking over, which is a
Yeah,
very
No
bad
problem.
idea.
I'm also
let's
learning.
let you, the
I'm also
steering wheel's
learning more
back
than
in
I
your
am.
hands, Lewis. Yes.
No problem. So the other thing is the from assets. So now he's gonna be I'm gonna bring the word value again. So it creates a value token with a specific policy name and quantity. Let's see the constructed.
Yes. So it is a function that takes a policy ID, asset name, and quantity and builds a value. So the previous one is when you
Okay.
don't have an initial value, right? You're just adding it to that value. This is when you don't have an initial value.
Interesting.
So you just have
say that again?
the quantity of this token, sorry, the policy ID, asset name, and quantity of this token, and then you build value from there.
Okay.
Are you clear the difference between add and from asset?
Add and from asset.
Good?
I'm good.
Okay, cool.
Yeah.
All right.
So then the other one is the transaction transaction library, right? So we have the inline
Okay.
datum,
Yeah.
input, and transactions.
Yeah.
As Harsha said, anything that starts with a capital P, I mean capital letter, that's a type.
Correct.
So inline datum
Oh,
is used to grab the data directly inside a transaction output, right? So grabs
yeah.
transaction data.
So it doesn't grab anything. So a type is something that describes something. It's not a function. A function does something. A type describes something.
That's a great,
You said a
right?
function does what? Grabs.
No, it does whatever. It takes an input, it does something, and then it gives an output.
Yeah.
That's a function. Types are basically describing. For example, let's look at this. Uh, Code
Yeah.
cow created a type, right? You see this type right here?
Mhm.
This is not
That's
doing
online.
anything, right? It's not taking an input and like somehow changing that input and doing something. It's literally just saying, hey, we are creating. So Oracle Datum is an object which looks like this. It'll have all of these fields. Okay. And its constructor is also Oracle Datum. So when you want to build an object like this, you use the keyword Oracle Datum. Does that make sense?
Kinda.
Let's unpack that because I think typing is super, super important. And the way Harsha described it, a type, which you picked up on as far as like you look for the capital, and that's a good signifier because it could be types and variables go together in my mind. But if it's a capital letter, it's generally a type, and types
Type, yeah.
describe something. Yeah. So
Yeah.
you picked up on that, and that's great. So you see how in line 19 it says type capital Oracle datum, and in the in line 7 the use statement from the transaction, those are importing types, inline datum, input, and transaction types. Is that correct? Is that what's going on there?
Yeah. Yeah. Those are all types.
Those are all types. Okay.
Yeah. But if you want to look at like what these types are, then we can take a quick look. For example,
Let's take a quick look. Yeah.
yeah.
Yeah, I love that.
So let's start with the transaction. Transaction is a big object like this, right?
Yeah.
And this
Yeah.
is like the most fundamental thing when you are writing an Aiken code. This is something you have to be absolutely uh, like
You're pretty much
familiar with.
always going to use this. You're always going to
Yes.
use this
Yes.
transaction because it's part of guess the redeemer, or it's used in all the different spin script purposes. Yeah.
No, a transaction is what you are sending in to the blockchain, and the validator either accepts the transaction or rejects that transaction.
Yeah, that's a good point. Yeah. Yeah.
Yeah. And so this is, think of it as like this big object with like multiple fields, right? And then input is one of the fields in transaction. So if you see input, you see this input?
Yeah.
It is
Yeah.
a list of the type input. So it
Oh
is a
my
list
God.
of inputs.
So
What?
input, the variable, is of type input. Very
Inputs the
sneaky.
field.
Yeah.
It has a
Inputs
list
and inputs.
of type inputs. And if
Yeah.
you want to see what the type input looks like, you have to go to input. So
Yeah.
an
Yeah.
input has this. Input is made up of output reference and output.
Yep. That's right there is like is one of those weird,
Yeah, it'll
an
keep
input
going.
is an output. You can loop around in that for a minute.
Yeah,
But once you
So,
get it, you get it. Yeah.
yeah.
so an input is an output. Huh? An input.
Exactly. Exactly. I feel like this is like I just like pardon the aside while the coffee just keeps going, it feels like it's like a different mindset, like cause and effect are the
It's because
same
you're
thing,
thinking
you
in
know?
English. It's because you
Yeah.
speak in English, you're thinking in English, and these terms of inputs and outputs are not made for you. They are made for the way to describe Cardano.
Yep.
And
Yep.
so your brain has a problem thinking that an input is an output because of English. But
Yep.
it's like the more you look at Aiken, the more you understand how UTXOs work, the more you're very okay digesting this concept that an input is just an output.
Yep.
It's actually quite beautiful. Like once you understand, like, oh, well, that's how they're all chained together, and that's how you get the unique hashes, and that's how this whole thing works,
Yep.
is through inputs and outputs, and yeah. So, but it's the first time you look at that, and for the first couple months, right? It's like,
Yeah.
it just reads weird. It reads odd if you're not
So
thinking in UTXOs.
so Don Lewis, you are in a special position because you are probably looking at this going like, and I was in the same position maybe a month ago. Harsha was in the same position maybe 3 or 4 months ago. So tell us, try to help us explain like what you are feeling and what you might be needing. Because and in my mind, this is the most important part because you're sort of just getting to know this, I'm assuming. So like tell us a little bit, like just free, just take the wheel for a moment and let us know what's going on.
Sorry, I don't get your question. In terms of,
Yeah, in terms of this, like of this idea about the inputs and outputs and how it sort of brings this whole cinematic universe of Cardano together. And that it is a bit weird for somebody that's just learning it. Um, does that ring true to you? Do you kind of understand that, or how do you explain the whole an input type is made up of the fields output, reference, and output?
uh, I just wait. So, as thinking in terms of what Code Cow said, sorry, I'm thinking in terms of English, right? So, an output could be an input, right? In terms of transactions. So, whatever you get as an output could be your input. I don't know.
No, so I can I suggest like something to think about. So
Mhm.
when you see the type input, I want you to think about the UTXO inputs you are giving in a transaction, right? A transaction will have inputs that you're trying to spend, and then it'll give out outputs that are the result of the spending those transactions, right?
Mhm.
So input describes all the UTXOs that you are putting into the transaction to spend.
So,
Does it make sense?
say that last statement again. Input.
So, okay, let me open my wallet right here, right?
Yeah, here we go.
So I have UTXOs. I have a bunch of UTXOs here, right?
Mhm.
And I want to say I want to spend this transaction. I want to send Lewis this transaction. I want to send 2,248 ADA to Lewis, right? I am spending this UTXO to send this value to Lewis. So this UTXO becomes my input, okay? And the final UTXO that ends up in your wallet and another UTXO with this random test token that will end up back in my wallet become the outputs. Does that make sense?
I want to say something. Will you go back to the what we were looking at before?
Here.
Just the inputs and outputs. Yeah. Okay.
Yeah.
So when Newman read this, he like had a brain melt where he's like an input and an output. Like what? And then the
Yeah.
way that Lewis read that, he kind of said the same thing. And what I am reading, listening to them, and what I've also felt when I was first learning was it feels like that's a circle. It feels like an input's an output, and an output is an input. and it's just a circle, and that doesn't make any sense. And I think, well, one, right, maybe I'm off there, but if I am right there, and like a newbie will read inputs and outputs and think of a circle and like get confused about what this is, it's better to think of a line. It's like an input turns into an output, but that output like it faces one direction, right? It's like going somewhere. And so it's a chain of these things, not a circle. I don't know if that helps.
I mean, it kind of does help. So with my explanation, I was thinking in terms of English and Ada and Cardano and programming. So yeah, it kind of makes sense. Full circle.
So, Code Cow, I have a small question. If I had to describe a specific UTXO, right? Do you think this is how I would describe it? Like a UTXO would have an output reference and an output?
I think it's more just the output reference.
So you're just saying it'll have like a transaction index and transaction hash.
Right? Isn't that's really all that you need to describe it at its fundamental level, right?
Correct. So where is this output coming from? Like who? So if all we have, like say for example, here all we have is just like literally this, the transaction index, sorry, the transaction hash and the transaction index is all we have. See here? So we have the transaction hash and transaction index. So where is this output part coming from? Like who is providing it? Is it the ledger that is somehow figuring out the output part of it and giving it to us? You know what I'm saying? Like, because all I see is just the output reference. So who is filling out all the fields in the output, which is the address, value, datum, all of that.
Is that when you want to spend it? I do understand your question, and I don't really understand how to answer it.
Yeah. So for example, like I'm trying to create a transaction that somehow interacts with the validator, right? All I have in my wallet is the output reference, which is the transaction hash and transaction index.
And
But
what can you do with
somehow,
that? You could send it somewhere. That's all you can do with that, right? You can move
correct.
it somewhere else. So I think, when you build a transaction, you are putting that output there. And when the chain
No, I'm
like
putting the
validates your
output
chain,
reference there. Where is the output
well, the
coming
output
from?
reference is like self. And then the output is the output. Oh, it's hard. Yeah.
I absolutely love it. I absolutely love it. Because it does get down into sort of this fundamental thing. And Code Cow, I definitely think of it as the chain, as the line, because it's a change in state. It's a change in like a transaction means something has changed in the state or the way things are. It's a transfer of assets. Actually, the instruction or the direction here is in the UTXO crash course. And I don't know if you guys remember this. And Lewis, you got to read the crash course like once a week. Like every time I go back to it, and every time I'm like, oh, there's the road. We've come across this before. We're like, we circle around something. It's like, oh, okay. So they use that post-it note, and that there is a reference that's written on the post-it note, and it's I would love to know that metaphor a little better, but it is there. And so I would suggest that we can look there at some point. But I wonder if we've learned
the
enough.
link for that.
Yeah.
I got you.
No, so we have the output reference that is described here, right? But the rest of the output part, this output part is basically describing that UTXO. For example, where is this UTXO existing? It is existing in my address. So it'll have my address at that point in time. And what is the value in that UTXO? So it'll go back here. It'll check the value. So it'll create a value object that is made up of ADA and this random token, right?
So
Yeah, it is basically it. So this whole information basically describes the complete state of of one UTXO at that moment in time.
Harsha, do you think maybe it would be cool to look at a transaction that has inputs and outputs, and we could, because right now we're just looking at UTXOs.
A transaction.
Yeah. So like just go to any
So this
transaction and we
is
should see, yeah, inputs and outputs. And if you make that bigger,
two inputs.
yeah.
Bigger as in
No,
like here.
I'm thinking of, yeah, there you go. So now you got inputs on one side and outputs on the other.
Yeah.
So
So
this, yeah,
so there are two inputs here, three reference inputs, one collateral, right? So these
yeah,
reference inputs are only being referred to, but they're not being spent. These two are being spent, and the collateral can possibly be spent depending on,
possibly be spent.
yeah. So these two are definitely being spent, and this is the result of the spending of these two UTXOs. These four are the result of it.
So the reference inputs, and that's of that 7RLTYF. So they are not in the outputs.
Because they're not being spent.
Yeah.
So they don't get spent. That's right. They don't get changed, we could say.
Yeah.
Yeah. You're
Yeah.
referring to them or reading some data from them. In this case, the script CBOR.
These are our is this a valid? These are validator.
Reference scripts. Reference scripts.
Reference scripts. Okay. Okay. So now that account hash 0 ASD. So that is subtracting. It's got that red test ADA. I love this stuff, going through this, because this is the real, this is a visual of what's going on in a transaction.
Yeah.
So we've got that, I'm just going to get the last three, the YFQ. So it subtracts a stereo token. It says a stereo token -1, a stereo token +1. Inputs.
So this UTXO is the UTXO I'm trying to spend from a script. This is a UTXO from my own wallet.
One wallet, yeah.
Okay. And this is the result of it. There are two UTXOs going back to the script, and there are two UTXOs coming back to my wallet.
Look at that. Okay. Because they're in the output and they have a plus, like in the ADA there, the plus T ADA, T, like the 1.5.
So anyway,
yeah,
so
right
if
down
you
there.
are just looking at the ADA, look at the total ADA that has been inputted, which is 561 point something plus 52 something. So that is 610 something ADA. And the output has 56 ADA here, about 56 ADA, 55 plus 1 plus 57, 57 plus 553. That is also about 610 ADA. So the total output ADA should be equal to the input ADA, because ADA cannot be created or destroyed.
I know, I've heard this before. And this balances, right? So what these outputs back to the script, outputs into the wallet. Interesting. Okay. Lewis, are you tracking with this? I think this is fascinating. I really think we could spend a lot of time like pulling apart these transaction details, because they are one way Like we build transactions, and this validator is going to build a transaction, and we can see it this way. Like this is a like a little viewfinder, like a display of all that data that goes on. So Lewis, I want to kick it back to you and see where you want to take us from here.
So do I just continue with where I left off?
Yeah.
It's up to you. You're the Don. You're driving us.
So now let's look into the cocktail library, right? Yeah.
Mm-hmm.
So can we leave still on inputs? So the check policy only burn. So that checks if all minted tokens are negative, burn only. Are we good there?
Yeah.
Are we
Okay.
looking?
Check policy. What is it? Check policy
Check
only burn.
check policy only burn. Yeah, that one.
So it is a function that takes a value and a policy ID and gives a bool. Check if a certain policy ID is burning only if it exists in the minted value. Okay, that makes sense. So it takes, so for this, you need to understand mint. Mint is just like value, by the way. And it will make sure that this policy ID exists and there's a negative value in it. A negative value means burn, a positive value means mint.
Negative value means burn. Positive value means mint. Yeah.
Right.
Yeah.
I think I got that when I was submitting transactions on the Andamio platform.
Oh,
Submitting
okay.
assignments when you
Hmm.
wait, hold up. Let me check my wallet. 1 second.
Yeah.
I wonder if looking at the source on this one might give us some insight. Yeah.
So they're basically flattening the mint. To understand flattening, it basically creates like a, I think, asset name, policy ID, asset name, and value, or something like that. And
Okay.
then it is basically checking if the mint value, and in the mint value, if X is equal to policy ID, if it is equal to policy ID,
That's
X dot third. Yeah. So basically,
yeah.
first is
The third
policy
is the
IDs.
value.
Yeah.
Yeah.
Third is not. Yeah. Third is the quantity.
Quantity. Right. Not value. Yeah, you're right. Because this is going with the value.
Yeah.
The
So it
mint
is.
is a value, and we know that the value is got those three things: policy ID, something, and quantity. Yeah. So yeah.
So now when you're minting, that's every time you send you submit an assignment, right? Or when you're signing up for the classes, or rather for the courses or projects, that's when you mint. And then when you unenroll, that's when you're burning, right?
You
Correct.
burn. Yeah, that's
Correct.
right. Yeah, that's right.
Yeah, so I think I got that from the Andamio platform.
And did you see where there was like a negative burn or a negative quantity in a mint transaction?
So every time the burn, I guess that's when you're unenrolling, right? So they give you
Yeah.
back your, is it collateral? I don't know.
Yeah, it's like your student token or something. Something gets handed back to you.
So when you're minting, that's when you get the negative. Then when you burn, you get the positive.
Yes.
I
Yes.
think,
That's right.
is that right? Yeah. Okay.
Mm.
So burn is
All right,
negative, mint
cool.
is positive. Yeah.
Yeah, let's go. Do I
All right.
continue?
Yeah, go for it. Yeah, that was a
Where
neat
were
little
we?
side trip.
Convert into, hey, convert int to bytes. Is that integers?
Yeah.
Yep.
Integers to bytes. Yeah.
Now I'm not really sure what this does.
You want to see this? Okay.
Yes.
Let's check it out. All right.
Convert an integer to a stringify.
So for this, you'll have to understand primitives a little bit. So how is integer represented internally and what is byte array? So what does that conversion even mean? So this is for you, Code Cow. Code Cow, you're around. Is this basically converting an integer to string?
Well, strings are not real.
Yeah, that's why I asked like if byte array is a
Yeah.
string.
No, right. Strings are not the same thing in Aiken. And I believe in the docs, it even says like, don't
Yeah.
use strings. This is only to
Yeah.
do traces. So
Right.
byte arrays are what we would normally think of as strings though.
Correct.
So yeah, I mean, I think that comment right above it is how, right. That makes sense to me. 1, 2, 3 turns into a string of 1, 2, 3.
Yeah.
Right. So it's not actually changing the numbers. It's just turning the int like into a string. Yeah. Right. The
Yeah.
way I would read it is turn it into a string, but that is the wrong
Yeah.
way to say it in Aiken. It's turning it into a byte array.
Yeah. Yeah.
Yeah,
It's a
this
byte
is
array.
yeah, it's worth, and I'll send over the link to you, Lewis. Byte arrays and strings have like a special thing in Aiken, and I think it's because string is less of a primitive. That the way it compiles, it treats strings like byte arrays. Now you can get around it a little bit, and that's what these functions are about. That's my and the way I deal with it is it's like, yeah, strings and byte arrays are a little bit, funky. So you got to downshift when you're working with them to like make sure you're using it in the correct way.
It's always a
And
byte array.
Yeah.
Everything is, and then a byte array is just bytes. So it's all bytes
Okay.
all the time, right? Like the string thing is an abstraction.
Okay. Well, we could, yeah. Okay. Yeah. That's right. It's farther up the abstraction chain. The
Yes,
string is,
yeah.
and so. All right.
Okay, so
Now, Lewis. Yeah. Now, Lewis. Now, at some point, and I'm just going to remind you that we are about halfway through. And with that being said, for the dear listeners that are out there, hey, do you know that you're tuned into the community code review, and that we are sponsored by Gimbalabs. We are all getting some bit from the community treasury, and it's just like, hey, if you're listening to this and you're like, I've got questions too, then hey, guess what? You can join us here live on Thursdays. You can hop in as a capo for the first times, or even as a guest. If you just want to be here live. You can ask questions, you can challenge ideas and give your input, and you can learn alongside with us. After a while, after you've come a couple of times, then you could become a Don. So this is what open source learning looks like, and there's always room for more folks. So that being said, back to
No,
the
like, how come you
back to
went
your
back to
regular schedule.
intro mode all of a sudden in the middle?
And I'm back. And then I'm back. It's like there's a little
I was so
switch.
confused. I thought he was asking me he's going to ask me a question.
No. Well, no, the question is, the question is, you can, because you're the Don and you're driving this little boat, and we are all on the boat with you and helping you learn. One thing that you can do is see where because we're learning all these little pieces. You can look into the validator logic and see where, for instance, check policy only burn, and that might give us some like practical context for how it might help. So I'm just offering that as like, hey, you could go down and check out the validator code too.
I was tempted to skip the imports and move on to the validator. So I wanted to like run.
Well, it's up to you, man. It's up to you, because I think this is valuable stuff, but it's sort of like, we have practical examples of each of these functions and types in the code, sitting right there.
Yeah. So guys here getting a bit excited to jump into the validator. So these other imports, they'll be available down in the code. So I would like us to quickly just run through some of these imports, the library imports.
Sure. Keep going.
So inputs with policy. So this one filters the transaction inputs to only those with a certain policy. Only minted token ensures that exactly only one token was minted with the expected name and quantity. And then we have the mocktails. So complete finishes building a test transaction.
Yep.
Mint, mint simulates minting or binding token.
Yep.
Mock policy ID. So this one creates a fake policy for testing, right?
Exactly.
So mock script address, same thing as creates a fake smart contract address. Mock TX hash creates a fake transaction hash. Mocktail TX. Starts a blank transaction, blank test transaction, if I'm not sure.
Yeah, it is like a, yeah, it is a blank transaction object. It's not a, it has dummy values basically.
Okay. TX in adds a fake input, transaction input, and then TX in inline data adds inline data to the transaction output. Now, I don't know if CodeCow mentioned anything about the Oracle. I remember he was saying something he was going to add.
Yeah, he
Then they
just added
did.
this type here.
Oh, okay. Well, I mean, we look into that type Oracle data.
So just do you want to just look at the fields?
Yeah. Or
Okay.
Interesting. Yeah, I'm looking at. Yep. So there we've got our byte array in winter, not winter, but winter.
when?
If it was me, I would skip this type and go read the validator because we're only using count in this validator. Again, because this
Interesting. Okay.
contract comes from a group of contracts, therefore it has logic that is combined and reused or needed for other validators. So in this DS NFT, we're only using the oracle.count. So if you wanted, I would comment out all of the other values in Oracle Datum right now besides count, and then move on
It'll
and
still
try
work.
to read the validator. The test won't work, but we can. It's okay. Just it will help us read it.
Oh, okay, that makes sense. So let me just jump to the validators.
But yeah, this part is.
Yeah.
Yeah,
Sorry,
it's
what?
just the redeemer has two types. One is the mint redeemer, one is the burn redeemer. Okay. Yeah.
Oh, oops. Thank you, Harsha,
Oh, for
for
sure.
noticing that. So this validator is a minting policy named DS NFT, I think, which stands for double spent.
Yeah.
So it takes one parameter, which is the Oracle NFT.
Policy ID.
Yeah. So it takes us as a policy ID. Policy ID for the Oracle token we use for data input, right?
It's just some random policy ID at the moment. We don't know
Okay.
what this is.
So mint. So that's a minting logic. It runs
Yes.
whenever someone tries to mint or burn a token under that policy. And the redeemer tells us what kind of action you're performing. So is it the mint or the burn? And the policy ID, I think we already mentioned that at the top.
Yeah.
And what else? The TX transaction. Yeah. So when redeemer is, right,
Mm-hmm.
that one is minting. So we're minting
Mm-hmm.
Mhm.
and we expect Oracle inputs with policy, TX inputs, Oracle NFT. So we must find one input in the transaction that uses the Oracle NFT policy. Think so?
Correct. Correct.
Okay. I like hearing all those corrects.
Yeah,
Nice.
and it is saying you need to find exactly one input.
One. Yeah.
And how did we know it is exactly one input? Even if this is not there, even if this comment is not there, we'll still know it's exactly one input that is expected. And how do we know it?
Oh, Lord. With the That's a good question.
What did you say, Lewis?
I said that's a good question. Since I'm the Don, Newman, would you like to answer that?
Sure. So when I see this, I say, okay, there's going to be this is how I would read that line. Then we're talking about line 42 here.
Yes.
Expect, that's just like, it's like a variable declaration. And it just says that there needs to be this Oracle input. And Oracle input, and I would highlight that and look for where it is in the code. Unfortunately, I can't bring it up on the
Like you
live
said, it's a
shares.
variable, so you won't find it anywhere in the code.
So it's being created at the moment. And then inputs with policy, so is a function that takes these two parameters, TX inputs and the Oracle NFT. And I know that the Oracle NFT was a parameter in the validator, and that the TX comes with the redeemer. So it's funny because
TX doesn't.
inputs with what's that?
Yeah. I mean, the redeemer, I think we are providing separately, but yeah, the transaction should basically have the redeemer as well, I think.
Yeah. Yeah. It's just there is so that you can reference the inputs from this transaction. So
Correct. Yeah. That is this
yeah.
basically transaction dot inputs, which is a
Yeah.
list, by
Yeah.
the way. Inputs are list.
Right.
So, okay, can I quickly read this so that
Yeah, and
it'll be
yeah.
clear?
Yeah.
So the way it is reading is expect a list. How did I know it is saying expect a list? Because of the square brackets. Okay. Expect a
Okay,
list
sure.
with exactly one input in it because there's only one item in it, right? So it is saying expect a list with exactly one input in it. And I'm going to call that input whatever, Oracle input. I can even change that name and say Oracle underscore I, or I can just say some
Yeah.
input, like it doesn't matter.
Yeah.
But it is basically just saying a list with one item in it. And
Okay.
this function takes a list and it filters the inputs into another list, right?
Okay.
It's taking all the inputs. It is checking which all inputs has the Oracle NFT policy, and it is giving a filtered list. Okay. And we are saying that
Okay.
filtered list should only have one item in it. Does it make sense?
Okay. Yeah, and Lewis, I'll put it back to you. Uh, does that make sense?
Yeah, it does. I had a question for Harsha. So you said the square brackets
Yeah.
Mhm.
expects any input, or would you say
No,
one
no, no.
input?
It's a list. Square brackets
Oh,
means a
expect
list.
lists. Lists.
Yeah.
All right, thank you, thank you.
Yeah, yeah.
So if there's zero or more than one, it will fail, right?
Yes.
Can you
So
test
this
that?
validator
Or
will
do you have
fail
to
at this
test that
line.
after?
And what's it? See, this is where I would go and look at inputs with policy.
Mm.
Inputs.
Because I think we looked at it
Yeah,
before.
inputs with policy is a function that takes a list of inputs, in our case, all the inputs from the transaction, and it takes a policy ID as the second parameter,
Yeah.
and it filters this big list of inputs and gives out a smaller list of inputs that has
That
this
has that
specific
policy.
token. Yeah, with
Yeah.
this any token with this policy ID in it. That's it.
So
Yeah.
what's to stop it from having more than one?
Because we are saying expect. If more than one happen, we are saying this thing should fail.
Right. And so basically the logic is determined by just having those square brackets. Um,
Not just having the square brackets, but also mentioning only one. Say for example, in this, if I can write it like this: Oracle input and Oracle input 2. That means
yeah.
what I'm saying is expect a list with exactly two outputs.
Does that
If
check
this
out, Code Cow?
Yeah,
Okay.
it's we've seen this pattern in other things that we've looked at.
Okay. Okay. So this is a way to validate that you have a list of one by declaring this by calling a method that returns a list and then expecting one by putting it in the square brackets with just one item. Am I saying that right?
Yeah, because the function's input with policy just returns the list. It doesn't matter, like that doesn't
Okay.
care how long it is. But we do. We are specifically saying that we only want one. And if
Yeah.
we wanted to say something else, like that's the place that we would do it. If we wanted 10
Right.
there, if we wanted 0 or whatnot, like we have that ability to say expect something very specific.
Yeah. And isn't there a function in one of these vodkas that has um like it's exactly one? Isn't there like a little helper function that does that, or is that the way?
There's some mint ones that are like they have opinion about only having one
Right.
minted
Right,
value.
right,
I'm
right.
not sure if they have a specific input. Isn't this one we're looking at a vodka one? Inputs with policy is
it
Yeah.
vodka,
is,
right?
it is.
Yeah, it
Yeah.
is.
So
Let's
I don't know if they have one that says in like only one input, but you know what we've written right here is
what
quite a
worked
clear
it.
way to say it.
Yeah.
And yeah.
Yeah. Inputs token.
Are you confused about anything, Newman?
No, 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 no. It's just, because of the robustness of the logic, is one of the keys, it's sort of like, and then this is a very elegant way of doing it, because if it's more than one, then it's gonna return false. Or it's gonna, because of the expect. Um,
It's not going
yeah.
to return false. It's just going to crash. That's what we want.
Yeah, that's true. Yeah, yeah, I guess that's true. Yeah.
Okay. So,
Okay. Yeah.
if Lewis, you are also clear with this line, we can move on to the next. We just have four more lines to go.
Yeah. And we got about 30 minutes. We
There
got
are
about 30 minutes in our allotted time. Right.
Yeah.
So where were we?
Yeah, line
um,
48 and 49.
input sequence. Okay, so okay. So expect. Wait, should I tackle that one? Oh yeah. Expect inline datum, input datum. So we expect the input to have an inline datum or data embedded in the transaction. If it's missing or hashed, it will fail. I remember last session. Oh no, was it last session? Or rather, let me ask this, yeah. If it's, oh Lord, wait. I know what I want to ask, but the question is jumbled. It's foggy, it's chaotic.
Yeah,
Hashed.
that's okay.
So
That's part of the learning. Now, um, you can ask somebody for help if you can get that sort of even the first step to it.
there's a hash data, right? The hash transaction. And then the other one is if it's not hashed, it's what?
What are you talking about? Like it like kind of went over my head. What?
Now I'm also confused.
Are you talking
Ah,
about datum, like datum hash versus inline datum?
Yes, that one. Thank you.
Okay,
Thank
okay, okay. Let's
you.
quickly do that. Okay.
beautiful. Nice.
So datum is basically just information that a specific UTXO can hold. Okay. When the UTXO is spent, the datum is gone. Okay. So it's think of it as just information that exists in a UTXO. And there are three things that can happen. Three ways like the datum. The UTXO can either have no datum in it, it can have a hash of a datum, or it can have inline datum. Okay.
Mm,
So inline datum is data. So for example, this is inline datum. You see this?
mhm,
Uh, so
Oh,
this
okay. Here we
datum is
go.
inline datum right here. You see this?
mhm,
So that means you can actually read that the value of the datum directly from that UTXO. Okay. And the hash of a datum is just the hash. You cannot read the actual value of the datum, but you can only read the hash. Uh, and are you familiar with the hash? Hash is a one-way function. As in, if you have a hash, you don't know what is the original data. Does that make sense?
That makes sense.
Yeah. So inline datum is when you can directly read the datum. Datum hash is when you have the hash of a data. That means if you have the original information, you can hash your original information and cross check if it is the same hash. So it is just like a cross checking mechanism. And no datum is just no datum. So are you clear with all three guys?
Yes, I am, ma'am. Thank you so much.
Okay, cool.
Yeah, that's great.
So moving on swiftly. Oh my days. Where are we again?
Just right here. You're
Mm.
right here.
Thank you. So expect Oracle data.
No, no, inline
Uh,
datum, the one above.
Yeah, let's keep on 48 and 49. Um, and 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 if you feel like you can explain it like in a sentence,
Yeah, yeah. Just
go ahead.
explain this. Just talk to us about what this means, and then we'll quickly move on to the next. It's not very hard. You got
I
this.
thought I did actually. So say moved on. So we expect the input to have an inline data. So data embedded in the transaction. So if it's missing or hashed, this will fail, right?
Correct, correct.
Yes.
And where are you
Mm.
getting that inline datum from?
I'm giving you a hint. I'm giving you a hint.
The Oracle input. Oh, who said that? Who said that?
So basically you're doing this if you get something with the redeemer of that's mint, you're going to find
Okay.
in these inputs a list, and if it's only one in the list, you'll get this value, this this
Input,
variable.
input. Yeah.
Yeah, it'll be an input because it's using this function. So you get this variable value, then which gets put here, and then this is of a the output and the I messed it up.
Okay,
Hold
so
on.
I think
Wait,
you
wait, wait.
already
Output and
said,
datum.
yeah.
Output and datum, and then it has to be of this type. So if it fits in with this type, if it doesn't, and this is all because of the expect. So if it fits with this type, um, then it will pass. It will keep going. And it will create this input datum field, which then we use in the next line down here. So you're basically grabbing this, making sure that it's a type, and you're creating variable input datum. You're making sure it's of this type because you're putting it inside of this inline datum. So yeah, that's how I'm reading it. And it just chains on with this because you're creating this here, just chains on with this. You're creating this variable here, then you're using it to create another variable and making sure it's of some type, which is the inline datum type. Is that I feel like I understand that.
I think you're right, you're right. But how do you know
Lewis, you start
that Oracle input has like an output section?
because it is of it's an input. It's an input.
Correct. Yeah, you're right.
Yeah. Which is from this transaction type. So you can go and look at that transaction type. This transaction type has all these fields, and one of them is input, and it's going to have an output that is datum. I think something in
Yeah.
there.
Yep. So
Now,
if you want to
Lewis,
quickly look at output,
yeah, let's do it. Let's do it in the transaction. Yeah.
yeah.
Oh
So
no.
it's just like going through it anyway. So
Yeah.
output has an address, it has a value, it has a datum, and it has
Data.
a optional reference script. Okay.
Yeah. So we're interested in that datum
In the
part, right?
datum. Yeah. Okay.
Now, Lewis, was that what you were sort of thinking?
Yeah, I guess so.
That's okay. That's okay. We can go on to
I got
this next one.
I got lost in
50.
between.
But I mean, now are you, so let's get you back in so we can go on to the next one, or if you want to reframe it in your mind, but get it in your mind before we go to the next one.
Okay, no problem.
And so, yeah, when you're ready, like, you can either sort of explain like what you're thinking or go on to the 5051, the sort of next, uh,
Let me move into the next
uh,
one. I'll
okay.
Yeah. 5051.
Yeah. So read it out first and then just try to explain it in English or how what you're going through.
Oh, I've been reading it from the other way around. No,
Oh,
it's the
okay.
other way around.
Whichever.
Rather I'm not reading the comment first. I'm reading the 51 first. That makes sense. Anyway, wait, no. That's one I just did.
No, the one you did was the one above this one.
Oh, okay. Jesus. They all look like lines to me now. Oh, no. Specifically type Oracle Datum with account field. Right? So we expect the inline datum to be shaped like an Oracle datum. So we only care about the count field, and others can be ignored using the dots, right?
Yes.
This one's interesting.
How so?
Right. So it uses this thing, which is there's a term for it. It's like it basically says, from my understanding, it says inside of this type Oracle datum, which is up here, on line 17. Whoever's controlling could get us up to 17. Harsha, yeah. So there's that Oracle datum,
Oh,
and then there's the count. And remember, CodeCal said that's the only thing that we're using. So if you go back down to 5051, so that basically says this. And it's interesting because it says this is of the type Oracle datum.
I mean, frankly, you don't need this in this case. You don't even need this.
Yeah. But
I
it's
love
saying
when
that,
Harsha corrects my code. It's like it makes my day.
I mean, but do you agree, CodeCal? Was that redundant because you had already had it here? It's sort of like it's double checking it, but it didn't break because it's running. So it's
Yeah,
just you're
I
like,
would at this point, like I've just come to start to trust Harsha's judgment on those things.
hey, all
Yeah.
right.
I shall say the same thing about you. Crazy.
That's so true, man. That's so true. Okay. But Lewis, do you see what we're doing there? Does that help you and get you
Yeah,
sort of
yeah.
started into it? Go ahead.
So I just continue from where I left off.
What did you say, Lewis?
I just continue from where I left off. So we have one more line before we finish and start doing the tests.
Yes, no.
Or
We have one more line before we finish our mint, and we have two more lines before we finish the whole validator.
Keep going, man. You can do it.
Okay,
let's
so
go.
now we have this
Right.
count.
So
Yeah. You can go to the next one. Yeah.
so we have the count.
Yeah.
Oh, okay.
So it grabs the count field from this input datum, basically. So you've
And then
you've
it
gotten,
has
yeah,
ignore the rest with the dots.
right. It doesn't care about that stuff. That's what that dot means. It means you can
Mm.
everything else can take a break.
So only one token is minted using count as asset name. So only minted token.
Do you want to take a look at the function?
Yeah, for sure. I was gonna, okay, yeah, for sure.
Yeah. Oh, right.
So it is a function that takes a value and checks if exactly one token is being minted in that value. And then it gives out a true or false.
So
So you
only
don't
one token will be
necessarily say
minted.
one. Like you can change it to any number, by the way, because this is an integer that you can set. You can say exactly 2 are minted, exactly 5 are minted, whatever. But in our case, I think it's 1. Yeah, in our case, it is 1.
Yeah, it's one, yeah. So it will mint only one token
Yeah, we are
under the
making sure
policy
it only
ID.
mints one token. Yeah.
Yeah.
Yeah. So it will mint only one token under the policy ID, and the name must be the string of count.
You got it.
Let's
And then
go.
this last one.
That's a burn now.
But why is that a
Well,
bun?
No, sorry.
It's a
the
mint.
next one. I was looking at the next one.
Oh, okay. Yeah,
Oh,
yeah. No, this is a mint.
You
If
know
it's a
what?
-1, then it's a burn. Yeah.
Yeah.
Yeah, yeah.
If it's a -1, it's a burn.
Yeah. So no, I was just talking about this function. In this function, if
Oh
you
yeah,
want
I
to
remember I
check
said
if it
that.
is burning, then you say a -1.
So move on to the next one, right?
Yeah.
Okay.
Yeah, you guys are good? Yeah? Okay.
Oh, this is good.
What?
Well, so you got this mint spin purpose, and it's basically it says, hey, look for this particular input, find the right, look for the input, find the right uh find the right datum, look for account uh uh data inside of that datum, and then it's gonna then make sure that it only mints one with this asset name. So that's all the minting. But you can also, with the same validator, you can also burn, and all it asks are that and then we'd have to look that it's negative, and I don't know why, I don't know where it would check policy only burn. Oh, okay, so it's going to be in this function logic that it checks that it's going to be
Check
a negative.
twice.
Basically, it's going to check for a negative number, I would assume. But it takes in the mint part of this transaction, and then also policy ID. Policy only burn. Because well, it's gonna ask for a policy ID at some point. Oh, in the
What
Redeemer. The Redeemer, yeah, it gets passed in this, so this policy ID has to be this. That's what that comes in
what is the
inside of
confusion,
there.
Newman? I don't understand the
No.
confusion.
I just lost my focus for a second because this policy ID is this. So it's when this Redeemer gets sent in, and the Redeemer is a a burn, then that policy ID and this TX and mint part. So that goes with this, and this goes with this.
Yeah.
Okay.
So you're basically checking that something is burning. You don't care how many are burning. You're just checking if something's burning.
Well, I mean, it has to be that policy ID, right?
Yeah.
Because it's
But
asking for the policy
I'm
ID.
saying we are not saying anywhere that you should only burn 1 or 2 or 3. You are saying just burn. As long as it is burning, something is burning, we are okay.
Okay.
Of
Okay.
that policy ID, that is.
Of that policy ID. Right.
Yeah.
Well, okay, now back to Lewis. Does that make sense? Or what's in your mind?
Yeah, that makes sense.